So the question here says, a random sample of 12 observations of a normal random variable is taken. The results give unbiased estimates for the population mean and variance as 10.24 and 0.52. Test at the 10% significance level the null hypothesis that the population mean is 10.6 against the alternative hypothesis that the population mean is less than 10.6. All right, so we've already been given what the null hypothesis is, right? That the null hypothesis is that the population mean is 10.6, and the alternative hypothesis that the population mean is less than 10.6. So if the null hypothesis is true, it means the distribution of the sample mean will follow a normal distribution with a mean of 10.6 and a variance. We've been given that the estimate for the variance is 0.52, so 0.52. So we can therefore find the test statistic, which we find as x bar minus mu over sigma over root n. So it means that t is equal to x bar, the sample mean, which in this case is 10.24 minus 10.6, and that's over the square root of s squared, which is 0.52, and that's over n. In this case, we've got 12 observations, so over 12. So this is what's going to give us the test statistic. All right. So the test statistic will be, therefore, if I use my calculator here, and we get negative 1.729. So negative 1.729 is the test statistic. Now, the critical value, all right, is a t-value at n minus 1 degrees of freedom. We've got 12 observations, so 11 degrees of freedom, and the p-value, if it's a 10% significance level test, then that's 0.9. All right, so we're going to make use of the tables to get that value. All right, so here we are saying 11 degrees of freedom and 0.90. So 11 and 0.90 should be 1.363. So that's the critical t-value here. So 1.363 is what will be heaven. All right, so the situation is like this, right? We've got our t distribution curve. The mean is right at the middle, and this is a lower tail test since it's less than here. So lower tail test, we know that this is the critical region, and the critical t value should therefore be negative 1.363, and this is 10% of the area under the curve. And we've also found that the test statistic is minus 1.7, which means it is lying in the rejection region, really. All right. So we're saying here that negative 1.729 is actually much less than minus 1.363. So therefore, we reject the null hypothesis. All right. And here, since we are rejecting the null hypothesis, it means that we are accepting the alternative. So it means that there is sufficient evidence to suggest the population mean is less than 10.6. So that will be the conclusion right here. And that's how we do it.